Hi, so today we're going to discuss about arithmetic sequence and arithmetic series. So first, let's talk about arithmetic sequence. Arithmetic sequence is a sequence of numbers such that the difference between the numbers is constant. For instance, we have the numbers 5, 7, 9, 11, 13. For you to know the difference between the numbers, you need to subtract the second term to the first term, the third term to the second term, and so on. So that 7 minus 5 is equal to 2, 9 minus 7 is equal to 2, 11 minus 9 is equal to 2, 13 minus 11 is equal to 2. So as you can see, we have a constant difference of 2. So that means this set of numbers is an arithmetic sequence. So next we're going to talk about explicit formula. So in finding the explicit formula, we have this equation of a sub n is equal to bn plus quantity a sub 1 minus 2. D stands for our common difference, and a sub 1 stands for our first term. So in our previous example, the arithmetic sequence of 5, 7, 9, 11, and 13, we're going to find its explicit formula. So first we need to find the common difference. So our common difference is 7 minus 5, 2, 9 minus 7, 2, 11 minus 9, 2, 13 minus 11 is 2. That means our common difference is 2. Then our first term is 5. We're going to substitute the given into our formula. So that's a sub n is equal to 2n plus our first term minus our common difference. So that's 2n plus 3. So now that's our explicit formula. For you to know if our explicit formula is correct, you need to substitute values of n. So that's a sub 1 is equal to 2 times 1 plus 3 is equal to 5. A sub 2 is equal to 2 times 2 plus 3 is equal to 7. A sub 3 is equal to 2 times 3 plus 3, which is 9, and so on and so forth. Next, we're going to talk about the formula for the nth term. So we have this formula of a sub n is equal to a sub 1 plus n minus 1 times b. So once again, a sub 1 is our first term, b is our common difference, and our n is the number of terms. Okay, so let's have an example. Suppose we have the arithmetic sequence of 3, 8, 8, 13, 18, 23, and 28. So we need to find a sub 10. So in the previous formula, we're going to substitute the given in this formula. So that means we're going to find the common difference first. 8 minus 3, 5. 30 minus 8 is 5. 80 minus 30 is 5. And so on and so forth. Now, a sub 10 is equal to our first term plus the number of terms minus 1 times the common difference, which is 5. So that's 3 plus 9 times 5 is equal to 48. So our 10th term for this arithmetic sequence is 48. So our next example, we have a sub 202. We're going to find the 202nd term of the sequence. So the same process goes on. We need to substitute the first term plus the number of terms minus 1 times the common difference. Then we're going to solve this. And so our 202nd term of this arithmetic sequence is 1008. Okay. Let's have our next example. Suppose you have an arithmetic sequence with a sub 8 is equal to 25 and a sub 14 is equal to 43. First, you have to find a sub 1 and then find b. So we're going to substitute the given into our formula. So that's a sub 8 is equal to a sub 1 plus 8 minus 1, which is 7, and the common difference. A sub 14 is equal to a sub 1 plus 40 minus 1 is equal to 13. We're going to substitute the value of a sub 8 and a sub 14. That's 25 is equal to a sub 1 plus 70. 43 is equal to a sub 1 plus 13b. We're going to name this equation as equation 1 and this is equation 2. So using the systems of equation, you will find a sub 1 and b. So first let's eliminate a sub 1. So that's 2 minus 1, which is equal to 43 minus 25, that's 18, and 13b minus 7b is 60. So d is 3. So substituting b is equal to 3 into 1, have 25 is equal to a sub 1 plus 7 times our common difference, which is 3, and that's a sub 1 is equal to 4. So our common difference is 3 and our first term is 4. Okay, let's have a next example. Find the arithmetic means between x plus 2y, 2x plus y, 3x, and 7x minus 4y. So first, you need to find the common difference. Since the second term and the first term is given, you can easily find the common difference. So that's 2x plus y minus x minus 2y. And that's x minus y. This could be our common difference. So now you need to add the common difference to our third term to find the fourth term. A sub 4 is equal to 3x plus x minus y, which is 4x minus y. A sub 5 is equal to 4x minus y plus x minus y is equal to 5x minus 2y. A sub 6 is equal to 5x minus 2y plus x minus y is equal to 6x minus 3y. So now we have the arithmetic means of 4x minus y, 5x minus 2y, and 6x minus 2y. Next, find the arithmetic means between 100 and 130. So as you can see, the given is only the first term and the last term. So our a sub 1 is 100 and our a sub 6 is 130. We're going to substitute it into the formula of a sub n, so to a sub 1 plus n minus 1 times t. So that's a sub 6 is equal to first term 100 and then to the number of terms minus 1, that's 5, and then 130 is equal to 100, it's 5. So our D will be 6. So now that you find the common difference, you can easily find the arithmetic means now. So you need to add 6 into 100, so 106, 106, 12. So now you can have your arithmetic means. So that ends the lesson for arithmetic sequences. Next will be arithmetic series. So, what's the difference between a sequence and a series? Let's have an example of a sequence. So that's 1, 3, 5, 7, and 9. And for a series, we have 1 plus 3 plus 5 plus 7 plus 9, and so on. So sequence talks about plainly the consecutive arrangement of numbers, and series talks about the sum of the sequence. So that means there's an operation involved when we talk about series, and a sequence is only the arrangement or the set of numbers given. So next we're going to talk about the sum of arithmetic sequence. We have this formula of S sub n is equal to n quantity a sub 1 plus a sub n all over n is the number of terms. A sub 1 is our first term, and a sub n is the last term. So for example, we have this arithmetic series of 5 plus 9 plus 13 plus plus 101. So in this kind of problem, we need to find the explicit formula first. So our explicit formula is a sub n is equal to 4n plus 1. So since a sub n stands for the last term, you can substitute the last term here, which is 101, into this explicit formula. So that's 101 is equal to 4n plus 1, 4n is equal to 100, and n is equal to 25. So that means the number of terms in this series is 25. So we're going to use now this formula. That's S sub 25 is equal to 25 times quantity, our first term 5 plus 101 all over 2. So this there. the sum of this series is 1,305. Okay. So let's have our next example. We have this sequence of 4, 11, 18 up to a sub 16. Since the last term is not given, we have to substitute a sub n equals a sub 1 plus quantity n minus 1 times d into the equation. So we have this formula of s sub 16 is equal to 16 over 2 times 4 plus a sub n. So we're going to substitute this with a formula on how to find the nth term. So that means we have 8 times 4 is a sub 1 plus n minus 1 times. Okay, solve. And then we have 8 times 8 plus 105. Now we have 940. That means the sum of this sequence is 904. Next, there's another symbol for you to know if you're going to take the sum of a specific equation in a given n. So this is what we call a sigma, and it stands for the summation of a certain equation. So we're going to find the sum of this equation. So that's s sub 100 is equal to 100 over 2 plus 1 plus 199 is equal to 50 times 200 is equal to 10,000. So that's the sum. Next example, we have, given that a sub 10 is equal to 10, s sub 10 is equal to negative 35, find a sub 1 and b. So that's s sub 10 is equal to 10 over 2 times a sub 1 is equal to 10. Negative 35, 35, a sub 1 plus 10. So we can now find a sub 1. So that's negative 85 is equal to 5a sub 1. A sub 1 is equal to negative 7. Then we're going to substitute this into the formula of finding the nth term, which is a sub n is equal to a sub 1 plus n minus 1. So that's a sub 10, which is 10. A sub 1, which is negative 17. Plus the number of terms, which is 10 minus 1, 9, and then times the common difference of 2. So that's 27 is equal to 90. Therefore, the common difference now is 3. Next, how many terms of the arithmetic series will give you a sum of 961? When the given is 1 plus 3 plus 5 plus etc. So that's s sub n is equal to n over 2 times a sub 1 plus a sub n. So let an be the explicit formula of this certain series. So that's 961 is equal to n over 2, 1 plus 2n minus 1. 961 is equal to n over 2 times 2n, and 961 is equal to n squared. So our n will be 31. So there are 31 terms in this series. Okay. So for our last example, a theater has 32 rows if there are 26 seats in the first row, 30 in the second row, and 34 seats in the third row, how many seats are there in all? So we're going to write the given sequence of numbers. So now, let's find the common difference, which is 4. And then, we're going to find the missing. Let's find for the last term, which is 32. So that's a sub 32. So a sub 1 is n minus 1 times 3. And a sub 32 is equal to 26 is 31 times 4. And our a sub 32 is 150. Now, we're going to find the sum. That's s sub 32 is equal to 32 over 2 times a sub 1 is a sub n is equal to 16 times 26. That's 100. So, our s sub 32 now is 80,860. So there you go. You can now solve for the arithmetic sequence and series now. And I hope you learned something. And thank you for watching this video. If you love this video, kindly like this video because this is our project in our mathematics subject. And so that's all. Thank you. Bye.